Uh, Good morning. Am I audible to you? Can anyone acknowledge, please?
Yes, ma'am. Audible, ma'am.
Okay. Is my screen
Yes,
visible?
yes.
Yes, ma'am.
Okay.
Visible, ma'am.
Okay. Thank you. I'll just start the session. I welcome all of you for the session two on the IEEE ISSS MEMS training program 2024. So, after the introduction, we are now going ahead with the software tool which is used by the designers for designing the MEMS sensors and actuators. So we will be dealing with the introduction to the COMSOL multiphysics tool, which is the one of the platform used by the designers to design the MEMS sensors and actuators. And then we will go ahead with how to download the tool from the iSTEM portal. So since COMSOL is a licensed version, so iSTEM provides a platform wherein the researchers can download this console tool and they can use it for their design and even the publish the papers. So going ahead, so what is basically a COMSOL multiphysics? So the engineers and the researchers, we use this COMSOL multiphysics to simulate the designs, devices, and the processes in all the fields of engineering that includes the manufacturing, engineering, and the research field. So COMSOL Multiphysics platform provides fully coupled multiphysics and also single physics modeling capabilities. Okay, so the simulator provides a wide range of possible operating conditions and physical effects, which makes it possible to use models for understanding and also design and optimize the processes and the devices for the realistic operating conditions. So we can use the COMSOL, which can be used to perform the single physics. We can have a single physics performing a certain simulations, and we can have two different physics, call it as multi-physics, that enables the designers to simulate the designs and devices as per their requirement. Okay, it has something called as a model builder, which includes all the steps that is required for the modeling workflow. So which includes the defining the geometries, the material properties, and the physics that describe specific phenomena, performing the computations, and then evaluating the results. So we will see what are those steps which will help us in modeling the COMSOL simulation. Okay, so with the help of these built-in physics interfaces and the multiphysics capabilities, we can build the models by defining the relevant physical quantities such as material properties, loads, the constraints, rather than defining the underlying equation. So here the equations are predefined, which works on the background, whereas on the front end, that is the GUI, enables us to enter the required geometrical structure, the material properties, and the something called as the boundary conditions, that is the physical constraints, which help us in the simulation. So this flow consists of basically 7 steps that is listed here. So the first step is to set up the model environment. So depending on the application, so we know that any object will be having certain dimensions. So it can be a 0D, which is a quantum dot. So 1D, one-dimensional structures, two-dimensional structures, and a 3D model. So this platform enables, am I audible?
Yes.
Yes, okay. There was some network problem. So this enables us to design the structure uh, depending on the requirement of the application. So we can go ahead with the 3D modeling. We can go ahead with the 2D and 1D and the 0D. So that is the setup, setting up the model environment. Okay. Then coming to the create geometrical objectives. So basically the geometrical objectives are, since we are going to deal with the MEMS sensors. Okay, so the geometrical objectives are nothing but the mechanical structures that we have designed as per the requirement. So we go with the selecting basically the 3D model for the MEMS. and then we create the geometrical objects based on the design requirement and the application. Then we specify the material properties. So we know that since we are going with the soy process flow, so the material properties will be basically a silicon. So otherwise, in any other application, depending on the application, depending on the process flow, we are going to choose the required material and the properties given by the foundries. After the third step, then we comes the define physical boundary conditions. So this physical boundary condition enables how the device has to interact with the surroundings. For example, if there is a accelerometer, okay, then the boundary condition would be a force, right? And since this is a mechanical sensor which has to sense the acceleration, this structure has to be fixed at certain positions which enables us to detect the force. So such conditions are called as a boundary condition, which tells how exactly the device is going to interact with the surroundings. So then we define the boundary conditions. Then we go to create the mesh. So mesh is one of the crucial step because it divides the geometry into the certain elemental shape with the different sized structures, which enables us to perform the background equations, which are in the form of partial differential equations. So instead of applying the entire force on the entire geometry and simulating, this will enable us to divide the entire geometry into a smaller units, on which all these equations which are running behind, depending on the physics, will apply, and then it will try to give the required accurate results. So then we go for running. After giving the mesh, we go to running the simulation. We run the simulation, and then we look for the results as whether it is meeting as per our requirement. So basically, a console is a GUI. We can see on this side here, right? So here, I hope you can see this. Right, we have I've taken a screenshot wherein the how exactly the COMSOL GUI looks. So I'll also give a flow of how the COMSOL simulation is done. So, but basically these are the steps. One is the model, choosing the required model environment, choosing the required structures or designing the geometrical objects. Then we define the materials as per the requirement of the structure. Then we define the boundary condition as per the application. Then we create the mesh required by the structure. So if there is a material which has a larger area size, then we can go with a fine coarse mesh. And if certain areas which requires a finer mesh, then the user can define the mesh size and also the shape, so which gives a better accurate results. Then we run and post process the result. I hope the process flow is clear to you. Then comes the module. So in the COMSOL multiphysics, as the name says, it is a multiphysics module. So it has set of modules that enables the researchers or the users to choose the appropriate model depending on their applications. So to name a few, so we have listed here, we have the acoustic model, so which where we can deal with the acoustic signal, basically the sound signal and the vibrations, which can be used for the applications such as designing the microphones or speakers, right? And then we have the semiconductor modules, which can be used to deal with the designing of new semiconductor material, for example, a MOSFET diode or any kind of a semiconductor device, including the thin film, can be analyzed with the help of a semiconductor module. Then comes the MEMS module, which is most important for us, which deals with various multiphysics, including the electromechanical concepts, piezoelectric, piezoresistive, or electrothermal, depending on our application needs. So the MEMS module basically is important for us to design because this has a set of multiphysics which includes the piezoresistive, piezoelectric, and electromechanics model, which is helpful for designing the MEMS sensors. Okay, so I hope there are many more applications which you can go through and understand depending on your need. Okay, so I'll just show a flow how exactly the MEMS design is done with the help of that COMSOL GUI. So shall we go ahead with that?
Yes.
Yes, please.
Yeah, yeah, 1 second. I'll just share the screen. Wait.
Yes, ma'am.
Yeah. Is the screen visible?
It's not a crime.
Okay.
It's a blank white screen.
Yeah, yeah. But can you see something is written like new model wizard?
No.
No? Okay. 1 second.
No, ma'am.
Okay, let me share it again. Can anyone acknowledge?
Yes. Yes. No.
Yeah.
Now it's
Okay. Yes, you can see some model wizard, blank model. The COMSOL multiphysics platform. Are you able to see?
Yes, ma'am.
Yes.
Okay, okay, thank you. So we can see here we have two set of options. One is model wizard and the other one is a blank model. So this is the platform of the COMSOL multiphysics. As I open the COMSOL multiphysics, this is what pops up. Okay. So basically, Model Wizard will take you through all the steps that will help you to design a sensor or the actuator. Whereas blank model, you directly go with the GUI and then you choose the required physics or the studies. Okay. So I will take you through the Model Wizard step, which is the most commonly used. Okay. So we click on the Model Wizard. Okay. And as I mentioned, so it gives the possible geometrical dimension that we can choose based on our application. So you usually go with the 3D structures. So we choose a 3D. Okay. Then depending on our application, as I mentioned, so you have a lot of physics that helps you to understand or analyze your device or process. Okay. So as a first step today, I will not be going ahead with the complete design. I'll be just showing you how exactly this tool is initiated or used by the user to design a sensor. Okay, so I'll be taking a simple example and I will take you through all the steps that is necessary for from the geometry to the results. So as I said, these are the physics that is important for us to design. Depending on our application, we should choose our physics appropriately. So today I'll be just going to design a simple cantilever beam. Can anyone tell what is a cantilever beam?
And one end is fixed and
Yes.
another end is free.
Yes, exactly right. So we have a simple beam, which is a rectangular beam wherein we have one end which is fixed and the other one end is free to move. So with the help of a cantilever beam, there are many MEMS applications which are actually in the market are done by the researchers, okay, which basically uses one physics, that is structural mechanics, because we are going to deal with the displacement and the stress experienced by the cantilever beam for the application. Okay, so in order to do that, we go with physics that is a structural mechanics. Okay, under that we have a solid mechanics physics. So you can see when I choose the solid mechanics, it basically gives brief idea on what exactly this physics is capable of doing. So we can see the solid mechanic interface is intended for general structure analysis of 3D, 2D, or axis symmetric bodies. So we can use this physics to design a mechanical structure in the form of 3D, 2D, okay, and enables to provide the displacement, stress, and strain. So these are the basic results that is provided by the solid mechanic physics. So these information is given at each physics that is listed here. So let us take a solid mechanic physics. I will add this physics. Okay. Then once I add the physics, okay, I'll go. You can see the green mark. It says study. So we have to choose the study. So you can see the listed here. The general studies are eigenfrequency, frequency domain, stationary, and time dependent. So basically, for a beginner, okay, we usually go with these four set of studies depending on our requirement, wherein the eigenfrequency study gives the information about the resonant frequency of the body. So how exactly the body moves, or the movement of the structure at the resonant frequency can be understood under the eigenfrequency study. Then comes the frequency domain study, wherein the range of frequency, how exactly the device behaves, that information is given by the frequency domain study. And stationary study is dependent on the static studies, that is given the force or the pressure, what is the response by the system to that applied force, that is given by the stationary study. And then comes the time dependent. So over a given time, how exactly the structure is going to move or behave, that information is given by the time dependent studies. Okay, so as I said, since we are at the beginning stage, I will just go with the simple study, that is the stationary study, wherein I will show how exactly the structure is simulated. Okay, so I will choose the study. You can see added study stationary, added physics interfaces, solid mechanics. Then I will choose a done. Okay, so basically this is the graphical user interface of the COMSOL multiphysics tool. Okay, where you can see you have a set of options which will help you to design the structure. So for example, if you want to add a material, so you can directly choose here, add a material. If you want to add a new study, since you go with one study, single study, as I mentioned, you can also go with the multi-physics. So if I have to add two more different or one more different physics, then I can add under add study option. Okay. But as of now, I have taken the solid mechanics as my physics, and I have added the stationary study here. Okay, so in case if I want to add other studies, I can choose this option, and from here I can choose the required studies. Okay, and if I have to add a physics, then I have to add physics from here. Any other physics for a multi-physics simulation, then I can add the required physics from here. Okay, and so I will now go with the simulation. Okay, so you can see what has to be the length of the unit that we have to use for the design, MEMS design. Can anyone tell the length unit? MEMS structure requires the length unit to be in which unit length? Micrometer. Good. Yeah, very good. So it has to be very good. Micrometer. So we have first thing, as we log into the COMSOL multiphysics, after choosing the required physics and the study, we have to choose the unit length, okay, which has to be micrometer. Make sure this is the first step, which is most important for you to choose.
Hello?
Okay. Yes.
Ma'am,
Yes.
this your which one screen is stuck at the stationary.
Oh, is it? Okay.
Yeah, yeah. It's not moving further.
Okay, let me share it again. 1 second. Thank you for informing. Is it visible now?
Yeah, yeah. Now it's
Okay.
visible.
Okay. Okay. Thank you for informing.
Ma'am, Can you do one thing? Can you only repeat from that ad study?
Yes, sir, sure.
Yeah.
From here, yes, or from the previous. Okay, let me start from here. I hope now it is visible. So I will choose the dimension. I will choose the physics, add, and then I'll go for the study. I'll add the stationery, done. Is it fine now? Ma'am, is it fine? You're able to
Yes, ma'am.
see? Yes.
Yes, ma'am. This is
Ma'am,
okay.
I'm not able to see it. It's stuck again.
Stuck again, I guess.
Okay, let me share the entire screen then. 1 second. Is it fine now?
Yeah, now okay, fine.
Yeah, you are able to see the GUI?
Yes, yes.
Yes, okay, thank you so much. So as I mentioned, in this is the GUI of the COMSOL, wherein after adding certain studies and physics, it is possible to add multiple physics as well as studies from the GUI. And we can see here, so this is the study where I can add the required study as per my requirement. Once a basic study is done, then I can add the physics for the multi-physics option from the set of physics that is available by the COMSOL. Okay. And as I said first in the beginning, we have to change the length of unit to the micrometer. So this is the first step that we should be sure about, that once we log into the COMSOL platform, we have to change the unit to micrometer. So once that is done, there are two ways we can build our geometry. For example, as I mentioned, micro cantilever is basically a rectangular beam, which has, since MEMS we deal with now three-dimensional structure. So what I can do is, I can right click on the geometry. Okay. I can directly take a block, right? So where width defines what is the length of the cantilever. Okay, I'll just give the scale as 1000 micrometer. Depth defines what is the thickness, okay, which is given by the foundry of the soy MEMS flow, right? And height defines the width of the structure. Okay, so I can give a three-dimensional measurement directly here with, if required, if there is any change in the position, I can just change the position of that particular geometry, and I can click on build objects. Okay, so you can see I have created a simple cantilever beam, right? So this is one option wherein I can build the geometry directly. Okay, there is one more option. Okay, I'll just delete this, which wherein if we have a complex structure, right, and wherein the minute structures connections are most important to know their positions and how they are aligned. In that case, what I can do is, under the geometry, there is something called as work plane. Okay, you can right click and choose the work plane option, wherein you can click on the plane geometry. You will be able to see the XY, the simple graph. Okay, in this simple graph, you can just give the width and the length, not the thickness. Okay, so it is basically a XY 2D graph wherein we have to build the structure by giving the X dimension and the Y dimension, not the Z, which is for the thickness. Okay, so now here I will have to draw the cantilever. So how will I do is, I'll right click. So I have the options here, circle, ellipse, depending on the structure, I will have to take one option, right? So as of now, cantilever beam is a rectangular beam. So I'll choose a rectangle. Okay, as I mentioned, width refers to the length and height refers to the width. Okay. So I have this option here, fit. I can zoom in, right? Zoom out and zoom the particular area. So when I choose this, I can choose a particular area. So these are the options. Okay. Now, once cantilever beam, it is two-dimensional. I have to make it three-dimensional, right? How will I do is, I have done this by taking a work plane, right? So I will right click here. Okay. Then there is an option called as extrude. So this option will give us to give the thickness in the Z direction, right? So I'll choose this extrude. Okay. And I have to give the thickness. So I'll give 10 micrometer and I will click on build objects. So you can see now. Okay. These are the all dimensions, right? You can look into the structure in different dimensions. This is XY, YZ and XZ. So basically we want to see the structure like this. So I will build the structure with the help of work plane. Okay, so this is another option. So once I click on the extrude, okay, then I have to form the union of the complete structure. So I have an option form union. So I'll just give build all. Since now there is only one unit, I don't have to worry about how the structures are defined, like whether they are intersecting, whether they are united, interconnected, with the boundaries defined, whether they are the junction boundaries are not to be seen by the external people or external simulators. So that option is also possible under the geometry, wherein you can see Boolean, partition union, intersection, difference. So these are the further options that is available under the geometry for the structure. Okay. And also it is possible to create the arrays, copy the structure, mirror the structure with reference to a particular reference X direction or the Y direction, right? All these options are available for a geometry. Under the geometry, so one way to build a structure in the three-dimensional way directly, or the other option is to right click on the geometry, take the work plane and then build the structure. Okay, then let us, after the structure, we have to apply the material. That is the next step. So how do we choose the material is, we go to the material, we can say entities needing a material. Since we go with the soil process flow, all the material requirement is which material? It is a silicon. Okay, so that is the information will be given by the foundries. So we go to the material, add the material, click here. We get the list of material here, right? So basically we're going to deal with which module? MEMS, right? So I have to choose a material from the MEMS module. Okay. Silicon is a semiconductor. So I'll choose a semiconductor, right? So depending on the single crystal silicon, it can be either, it will be mentioned by them whether we have to take isotropic or anisotropic, right? So as of now, I'll take one particular material irrespective of isotropic or anisotropic, right? So I've taken isotropic and you can see here, I have chosen to all the domains the same material. So I'll choose the material and I will apply to the structure. Okay. So you can see there are some material contents, right? So the density of the material, Young's modulus, Poisson's ratio, thermal expansion coefficient, heat capacity, permittivity, conductivity. So these information, if not all, at least the Young's modulus and the density, those information will be given by the foundry. Please make sure whenever you do a design, check for the material properties and enter the same properties given by the foundry. Okay. So now I have chosen the material, that is silicon. I have applied on the domain, complete domain, right? Next step is to apply the boundary condition under the physics. So all these boundary conditions comes under the required physics. Okay. Since I'm dealing with a cantilever beam wherein I am just checking for the displacement of the beam for a applied force or pressure. What are the two boundary conditions? One thing is the fixed constraint and the other one is the load. All right. So from the under the solid mechanics, when I right click, I have these options, right? Boundary load and the fixed constraint. So I will take the fixed constraint and I will just rotate and apply here a fixed constraint. Okay. The other option is the load that is under boundary load. So whenever I'm applying a pressure or force, it is taken as boundary load. So I will take a boundary load. I have to choose where exactly. So selection of the dimension or the face where exactly I'm applying, that has to be selected, right? And then what I'm applying, the load type, whether it is force per unit area, total force, pressure, depending on the application, right? So if I'm doing a pressure sensor, then I have to choose option of pressure. If I'm doing some force measurement, accelerometer or anything as such, I have to apply a force. So let me consider a pressure now. So as of now, randomly, I'll be including the value of 1 Pascal, but make sure that this load type depends on your structure, which will be detailedly explained in the next sessions, how exactly we choose the value of the pressure or force that has to be applied here. Okay, so after the material, now we have applied the boundary conditions. One is load, the other one is fixed constraint. Okay, after that, the next step is to mesh, right? So you can see it is physics controlled mesh with elemental size being normal, right? I'm not going to worry about the size here. I'm just giving a normal size because it is uniform structure, and this is just a trial run where I don't have to spend much time on the simulation. But if we really go with the accurate results, then we have to go with different elemental sizes depending on our requirement of the structure. Okay, and this may take a longer time when we go with the extremely fine or extra fine mesh size, right? So as of now, I just gave a normal mesh. I have not given any defined any type or the size. Okay. And then the last step is to go for the study. So I'll click on the study and I will compute. Okay. So this is what the result we got. So what we can see here is the result in the form of stress, that is von Mises stress, which basically tells about how the material deforms under the complex loading conditions. So this is basically yields whether we go with the we can go ahead with the applying further pressure or the further process, the force, which or whether it yields any plastic deformation or the fracture. So basically, von Mises stress is the the stress plot given by the system, which helps us in predicting the whether we can go ahead with the simulation further by applying further force, or whether it will deform, resulting in the plastic deformation, right? So what we can see here is the color gradient. So we can see, since we have fixed this end, okay, basically a stress is force by area. So it is a restoring force which restricts the motion for the applied force, right? Since we have fixed here, we can see it is opposing that force at a greater extent. That is, the value is given by about 2.5 into 10 to the power 4 of Newton per meter square, right? And since the other side, blue side, it is free, we have not fixed, it is free to move, and we can see some displacement, right? So it is displaced because of the pressure that we applied on the cantilever beam. So to know exactly what is the exact value, see here it is a gradient. We cannot exactly measure what is the value of the stress, right? We can go with, under the results, derived values, right click, we can go with the point evaluation, right? And we choose a point where exactly we want to see the stress, okay? And then we have to choose an option here for the expression. You can see here under the expression, which physics we have chosen? Solid mechanics. So under the solid mechanics, we have to go with stress, von Mises stress, and evaluate. You can see here under the table, this is the value, exact value of the stress at this point. So if at all we want to make at different locations, what we can do is we can simply put a simple uh, rectangular or square uh, here within where we have to measure the stress point, and then we can choose that particular point for analysis of the stress. And if we want to measure the displacement, right? So what I can do is I can choose the point of displacement where I found here is the maximum, and I will choose a different expression, that is displacement from the solid mechanics. So I'll go here under solid mechanics, displacement and the total displacement and evaluate. So you can see here displacement is about 0.0087 micrometer. So for a pressure that is 1 Pascal, for this structure, it is able to give 0.008 micrometer or 8 nanometer displacement. And the stress is about 18097 Newton per meter square. Right? So this is how a COMSOL can be used, wherein we build the structure, add the material, apply the boundary condition on the physics by using the physics, and we mesh the structure. We divide this entire structure into smaller elements wherein all these partial differential equations are applied. We can see here under the solid mechanics, you can see the equations, right? So likewise, each physics has its own equation that is solved on the background, right? So this enables us to simulate the structure and give the results. Okay, so this is about the flow. And on the Tuesday, Nitya, she'll be teaching about how exactly we are going to design this cantilever beam for a given specification. So I hope this flow was clear to you, right? So shall I go ahead with the next, that is on the how to download the tool from iSTEM portal, right? So this is most important because most of you, if you do not have the COMSOL multiphysics, then the iSTEM, which is a national portal that provides researchers to locate the specific facility that is important for their R&D work, right? Which is closer to their location. It can be either using some characterization tool, which can be either XRD, SEM, depending on the requirement, or it can be few softwares. So there are 4 to 5 softwares which is available on the iSTEM portal, which out of which the COMSOL is one of them, right? So how you can do is you can download the COMSOL from the iSTEM. So go to the iSTEM portal, right? Then first, initially, you have to register with the university ID. Make sure you don't register with your personal IDs. It has to be a university ID, right? So register as a first step. So we can see here, it is institution or the researcher. Since you are going to deal with the researcher individual system, so you have to register under the researcher or user registration. So this is the second step. So go to iSTEM and register as a first step. So it will basically gives, require some information, which is the mail ID and the phone number, right? And other information regarding your whether you are a student or you are from the academic or from the industry. All those information will be given by the iSTEM registration, right? So provide the details and make sure you give the email ID as your university email ID and the contact number, because both are important for the verifying the user ID that you have created. Once you register, okay, you will have to verify both email ID and the mobile number. Only if they match, you can download any software or access any sources for your characterization, right? So give the details as per the required format. So once after that, you will receive a mail from the iSTEM. They will provide you user name and the password. All right. So once after register, you will receive a message from the iSTEM portal, which will give the username is not mail ID or something. They will have their specific username and the password will be given by them. The same username and password has to be used when you log in. Okay. You can see. So once you receive, then you will have to go with login option, wherein you have to include the login ID given by the iSTEM and the password given by them, and include the captcha and log into the iSTEM portal. Okay. So before you go ahead with accessing any software or the characterization facilities, okay, you have to verify the email address and the contactor number through the OTP. So once you log in, okay, there comes a window wherein you have to verify the OTP and OTP with respect to the mail as well as your contact number, right? It should be same as given in during the registration, right? And there is one note I have put here. Kindly note, email verification OTP will take approximately 5 to 15 minutes. So the mobile OTP will be received immediately, whereas for the email, it will take some time. So don't type the OTP which is sent to the phone for the email wherein email OTP is has to be entered. Please wait. They will send the OTP. Don't do multiple entries or click multiple times, because every time you click, they will generate the OTP and later you will be confused which OTP is the exact OTP required by you, right? By the iSTEM. So just please wait. Once you log in, please wait until you receive the OTP for the mail, right? Until then, you cannot go forward, right? After the verification, after the OTP is entered, contact number OTP is entered, then we can proceed for the further. Okay, so you can see here software through iSTEM. So you can click on the software through iSTEM, okay, where you can see the possible softwares that you can access, right? You have the COMSOL, you have MATLAB, LabVIEW, and CoventorWare. So depending on your requirement, you can choose any, but as of now, we are working on the COMSOL, so I'll have to choose the COMSOL. So as you click on the software through iSTEM, this window shows the possible possible softwares, right? After that, we have to go with COMSOL Multiphysics, right? So this is the version given by them, 5.6, and we have to choose a request for the COMSOL, right? This is the option where we give a request to access the COMSOL Multiphysics tool, right? So after clicking the COMSOL Multiphysics, click on the request COMSOL, before which you have a set of instruction given by them and few links which enables you to tell how exactly to use the physics tool, right? And what are the modules available under the COMSOL Multiphysics, right? So request for the COMSOL. So you can see, as I mentioned, so basic module, basic plus advanced, and help and support file. So basically we have to choose the basic plus advanced modules. Make sure you don't go with the basic because MEMS is required. So it comes under the basic plus advanced modules. And if there is any multi-physics requirement has to be done, then it is through the advanced modules, right? So choose the basic plus advanced modules. Then once you choose the modules, okay, there is a request form wherein you have to enter your details, right? The contact number, organization, if it is required, you can enter, which is not mandatory. And you can see the modules information, right? So depending on your requirement, what you can see here, note, you are allowed to request maximum 6 modules. Okay, so you can, depending on your requirement, make sure the first 6 modules are as per your application, as per your need. Okay, so choose the 6 options accordingly, right? And then you have to give the host name of the system. So I will show how exactly. I hope you are aware of the host name. So it is like once you log in through your system, okay, you have to give the host name of the system wherein you are going to download your software. So make sure don't you have to give the host name of the system where you're going to install the console software and its ID number. Okay, and ID proof, it can be any ID proof, student or employment ID, right? You have to include the ID and then click on the I agree, right? And then you will get this. So I click on the I agree and you can submit the final application for your console. Is that clear? So I have put a drive link, which this information is also given in the iSTEM, or you can access through this link wherein I have included a file which shows how to choose the host name and the ID number, or else I will show in now itself in the presentation. Okay, so make sure the host name and ID number should be the one wherein you are going to install the console software. Okay, and make sure it is one user software. Don't share your credentials with anybody. It is for individual user, individual system, right? And individual credentials. Don't share it because it is most important to make sure you do not get into any troubles further, right? Once you register, you will receive a mail, right, which has the guidelines on how to install the console. So easy steps which are given by the iSTEM user. You have to use their port number, host name, and then the device name should be of your laptop or the system where you are going to install the console, right? And then you include the steps which is given by the installation guide, and then you can install the console software. But this will take 2 to 3 days of working days to send the request. So once you make a request, they will take 2 to 3 days of time to send you the instructions as on how to download the console software. Please wait up to 2 to 3 days. If not, you can just they will share their email ID or the contact number. You can contact them and request for the console software, right? So one more important thing to say is, okay, so before this was the grant information about that. So, but when you make a request, you will get this email wherein the request is made, right? So request for using console software. So they will share the credentials. So this is the first step, and before which I have included this, right? So once you immediately register, you will receive this request email wherein they will give the referral code that this is registered, that the request is registered by the iSTEM. Once they verify all the credentials, all the details, they will grant the permission with the installation guide. Okay. One more important thing I have included here, request for CAD kernel. That means, see, this console can be saved in the form of .mph file or some bit form. But if you are comfortable with some other tool like finite element analysis tool like ANSYS or some other platform wherein you are familiar to do the design structure, in that case we have to import in other format like .stl, .igs, .stp, right? In that case, if just look into the console once you install, just see if it is possible to import or export such files, right? If not, if you are really in need, then you can request the iSTEM to provide CAD kernel. This enables, the CAD kernel enables you to access or import or export a different format of the files, right? So this is about the flow, how exactly we are going to request or download the console software from the iSTEM. Make sure you register to the iSTEM, right? And then you wait for verify your details, user details, right? After verifying, you can wait for verifying your user created user ID, which is created by uh, the iSTEM, right? Through OTPs, which is one to the mobile, one to the email ID, right? And after verification, you can go ahead with all these steps and then get your console downloaded, right? But make sure the device details should be the one where you're going to install, right? So I'll just show how exactly. Okay, you can go to this PC. You can click on the properties. See this device name. You're able to see, right? Can anyone acknowledge, please?
No, ma'am.
You're not able to
Yeah, now
see?
it.
Yes, yes.
Yes,
Yeah.
yes,
Yes. Yes. So this is the information that you need to enter when you request for the console. Device name is your laptop details and device ID is this. So they will give the access to use those console software only for these mentioned device, not any other. Please make sure you download for your system with your user ID. If you want to have another set of software, the modules, then please log in, register again with the different university email ID, and then download the required modules. Right? I hope uh, whatever the information I shared was clear to you. Right? Just a second. I will be sharing the feedback. Please fill this feedback. I'll be putting under the chat box. All right. I request all of you to give the feedback on this. All right. Any doubt? See, you will have to download this. I'm not sure if anybody has the comms, or if you want some time to download, please take some time. Register today because Saturday and Sunday are usually off, right? So they start from the Monday. So if you can register today and Monday, I hope they will look into the request and grant the access. Or if not Monday, Tuesday or Wednesday, they will take some time to verify and grant the access. Then once access is granted, then you can download and just start using the flow. Just try to follow the flow which I mentioned. And Tuesday, Nitya will be taking you through the design steps of a simple cantilever beam, which will help you to understand the design aspect. Is there any queries?
Mom, this form, Google form is not opening.
Is not opening? Okay.
Yeah.
Okay. Let me try.
If it is
Hello,
open,
madam.
maybe
I think
you
it
have
has
to click the
copied
category.
Hello.
everything.
Ma'am, it's opening.
Let me please try, ma'am.
Full form
Can
is
you try this next?
Hello.
Yes.
Yeah, yeah.
Madam,
Now it's open.
can we use lower version console? Is it
Yes, sir. If you have, you can use it. But if at all, if somebody else who has the higher version, then also it's fine. It is not like if you have a higher version, then the lower version simulation can be opened. So there is no problem. But make sure you have all the possible multi-physics options
Okay.
depending on your requirement. If that is there, then it is fine, sir. Lower version is also fine because it starts from 5.6.
It's
So
already
6,
with me, but
6.2. Yeah,
software,
sir, you
lower
can
version
use.
software it is there.
Yes, sir, you can use it. And we have inquired the iSTEM regarding the publication of the work which you are planning to do. So they have given the acknowledgement. They have replied by saying that we can publish the work which is done with the help of a console downloaded from the iSTEM, but we need to acknowledge them. So if the one who had query on this, it is possible to publish the work. Only thing is we have to acknowledge the iSTEM for providing the software.
Okay.
Yes. Any other queries?
Is WhatsApp group?
Yes, sir.
Every time checking mail is difficult. WhatsApp group.
Okay, you want to create a WhatsApp group? Fine, sir. We will create a WhatsApp group. But we need to, we will share the link on the email so everyone can join to that group. Is that fine?
Okay, thank you.
Yes. Any other queries?
Ma'am, I have a question here.
Yes, yes, sir.
I'm sorry, but just to tell that
Yes, sir.
at the moment I'm not employed.
Okay.
So I will not have a university email or
Yes, correct.
institutional email. Then what
Right.
happens?
Actually, they need a university. If you have any friends who can, or the students who can help you, I think, because they need a
So,
university ID.
Yeah, but in that case, then confirmation of the email also I'll have to route it through them, right?
Yes, yes, correct, sir. And
But then if I am giving the machine ID of my personal laptop,
that
how
is
that
fine,
works?
sir.
Will
That
that
is
not
fine.
be a
No
issue?
problem. No problem, sir.
Oh, okay.
That can be done.
I
But
think
if he has to again download from in his system, then he has to either ask for 6 more modules through his friends or something. Make sure you
Yeah,
that is how they follow. So he can use other things. So other user
yeah,
IDs and
I'll
things.
have to find out some person who is not
Yes,
into MEMS or these kind of thing, into
yes,
something
yes,
else alternate.
yes, yes, exactly. So any other doubt? I guess Rakesh.
Yeah, ma'am. My question is, when you say institution email ID, you
Yes,
mean university email ID
yes,
only?
right, right.
Specific university. So,
Yes,
a person who are now part of the university can only avail this option, right?
yes. That is their requirement. They have to be registering through the email IDs of that is of university.
Industrial email IDs are not allowed.
Allowed, sir. It can be.
we can
Oh.
upload the like proofs of that we are a part of the university, something like that. I think that should be sufficient, I guess. Because in
Yeah,
many places there are no university email IDs available.
yes.
Okay, but I still
We
because
can.
I registered with my personal email ID. There was
You
no
have
issue.
received. Okay, okay.
Yeah, I
So
was
the
able to register with my personal email ID.
okay, sir. Okay. So
Yeah,
okay, sir. If that is the case, then it is well and good. So
yeah.
try once.
That will not be an
If
issue because so when you are requesting for the yeah, what is that our account, say let us say console license, I think they
yes,
are
sir.
already asking there your university ID or the affiliation related proof. Okay, I think
Okay.
that they are going to check and they are going to give the license.
You can try that, sir. But as per
Should be fine, I
my
guess,
yes, as
because
per
they are not, they have not mentioned that it has to be university email ID or something. I mean, as far as I remember.
okay. I'm not sure exactly, but when we tried, like one of student faced issue with the email IDs. So if once if you do not have, you can try. If not, you can just request you can call the ISTEM, take the help, and see if you can go ahead with the Gmail IDs, the personal IDs.
Yeah, because I mean I am telling no, so I have created
Yes,
with my personal ID and there was no issue. I was able to
you
log
got
in.
the comms also.
The console I did not get.
Yes,
That's no like okay. I think you are saying for console getting console you will have
yes,
to use the
yes. That is what like few of us when we downloaded like one faced the issue with the email ID, and it was like they could not do it because they have to recognize them as academics person or a like from the
for
industry.
persons. They
Yeah.
already they are asking for the proof. No, some proof
Yes,
like
yes,
ID something.
yes.
That should be fine. I guess probably. So let me
Yeah,
try.
probably you can try, sir. If not, just try with the university or the official IDs.
Ma'am, 1 second. I think I got a little confused here. So, means that I can use my, see, I'm not part of any university, but I'm part of a startup. Okay. So
Okay.
I can use my company email ID,
Yes,
right?
yes, yes,
That will
yes,
work. All right.
yes.
That's all I wanted to confirm.
Yes,
Thank you.
yes, it works. So if you are academic, it has an option whether you're from the academy or industry. So
Okay.
you can enter your official ID.
Perfect. Thank you.
Yes. Any further? There is no quiz because I thought it's just an introduction part. So uh, I have not kept any quiz as of now. Maybe henceforth in the coming sessions we'll keep a quiz. It's only the feedback I've taken. So I hope the session was useful to you, right?
Yeah,
Shall we
and
end?
when
Yes,
somebody is
ma'am, very useful.
basic 6 modules that we can have for now.
Yes, yes.
So
Make sure that depending on your requirement, you can choose. Basically, MEMS module is most important. If you want us to suggest modules, we will give the list. Is that you require? Anybody who is in need of what could be the possible modules?
yeah, so probably
Okay.
basically this is a community chip, right?
Yes.
So because some of the modules, all the modules cannot be used
Yes.
there, right?
Yes. Right.
Based on the most common modules you can suggest, and
Yes.
based on that,
Sure,
anyways,
sir.
to follow the guidelines and make the, like say, designs, right? So you can
Yes.
give
Yes.
suggested modules, you can tell, and based on that we can request.
Sure, sir. Okay, sir. Thank you. Any other queries or?
Ma'am, one more thing is here, like a
Yeah.
Tuesday, no? Tuesday also from 10:30 to 12, right?
Yes. Yes.
We all working professional. We have our own duties here. So
Yes.
regarding the attendance, ma'am, you're compulsing for 90% of attendance, right?
Yes. Yes.
Yeah.
You can, in that case, you can just drop a message since we are creating the WhatsApp group. So you can drop a message regarding your inconvenience on the joining the session.
Okay, fine.
Okay.
No, it's not about joining the sessions. Like say we miss out the live questions, anything we like at that time. So like at the same time I have class.
Yes.
Ma'am,
Make
one,
if
I have sure.
yes.
So
ma'am, one more
Yes.
thing is last Tuesday happened, no, so I could not attend that. If you once after creating this WhatsApp group, no, can you
Yes.
upload that YouTube link?
Yeah, sure. We will upload. Even the today's video will be uploaded on the YouTube, so you can watch. You can go through both videos.
Yeah.
Okay.
Actually, I don't have problem with the Saturday class, only on
Okay.
Tuesday. Yeah.
Okay, ma'am. You can just drop a message there.
Okay. Thank you.
Yes. Yes. I hope the session was useful. We will see you again on the session 3 next week, which is on Tuesday, right? And again on Saturday, which where I'll be taking the session, right? Shall we end the session today?
Sure, indeed, very
Yes.
useful. Thank you so much.
Thank you so
Ma'am,
much. Thank you. Yes.
ma'am, hello.
Yes.
Hello. Good morning, ma'am. Please share the link of that group or WhatsApp group.
Yeah,
Actually, I
sure.
have also same concern because of the classes and everything. That's why
Okay.
I will also drop that message.
Yes, we will share the WhatsApp group details on the mail. So after that, you can join. All right.
Okay, ma'am. Okay.
Okay.
Thank you.